Let's go to question number 528. Random pick with weight. This is medium question. Let's get into it. This one, even it has a lot of some down, but I think question itself is really good. But I think the question description of question has some issue because it's easy to confuse. So, okay, let me read it first. You are given an array of positive integer a, where a is describe the weight of ith index, and then it starts with the 0. We need to call the function fig index, which randomly return an integer with the range 0 to weight rate minus 1. Pig index should return the integer proportional to its weight in the W array. For example, for W1, 3, the probability of picking the index 0 is 1 divided 1 plus 3 is 0.25, that is 25%, while the probability of picking the index is 1 is 3 divided 1 plus 3, 4 is 0.75, this is 75%. More formally, the probability of picking index I is Wi is some W. Yeah, then. Okay, let's take the example. Okay, let me use this one. W receive this one, and then this one means let me make the certain array that this one is index start with 0, right, and the 0, 1, and then this one represent the possibility is 0 is 1 divided 4, that is 0.25, right? So we also express like this, that is 0 and then 3, 1, and then we able to pick one of them. At this time, this one is probability is 25%, and then this one is the 75%. That just makes sense. But one of the issues is this one is really big number. Then we also needed to really pick the space complexity. So I think this is not the best solution. So how we able to make it better? How we able to make better? That's right. We able to use binary search, and then we use bisect left. So, and then first I'm gonna make cumulate sum, and then that is first is 1, and then second is 4, right? So I will get random value 4, and then this one is smaller than 4 and between 1 to 4, and then I will return each index. This is 1, and then this is 0, and then range is below the 1, and then I will return 0. Then we can make the same result, right? Awesome. So let's make self cumulate sum, and then first item is must be W 0, right? And then for I in range from start 1, because we already put the first index, and the 2 lengths W, and okay, self com append. First is value, best value is self com I minus 1, and then plus W I, right? Now we just made cumulative sum, so return. Okay, let me use the bisect left. Bisect we put self accumulate sum, and then target is self accumulate sum in the biggest number, right? Random dot random. So this is from 0 to 1, and then we can get value, the range of the yeah. And then, okay, let's check the code. Okay, looks good. Alright, then okay, we solved very quickly, so now time to ask to interviewer, should I make custom binary search? If interviewer okay, let's make binary search left, and then target, and left must be start with left is 0, and then right is last index of nums, and then while left is does not same as right, and then let's calculate mid value is left plus right minus left divided 2, and then if nums mid is smaller than target, it's time to left immediate to move +1, we go to right side, right versus is mid. If the otherwise, we choose left side and then return left. Okay, let's check the code. Okay, looks good. Time complexity is in the initialize. Time complexity, it takes the linear time because we use one iteration, and space complexity also linear space because you use cumulative sum already. And then peak index, we use binary search, so time complexity is log n, space complexity is constant. Thank you.